In this example, we're going to talk about one-sided limits. So here we have a function, right? This function that we are looking at, f of x is equal to x divided by the absolute value of x. And so the graph looks like this two-piece or this step function in a sense that we see over here on the left of the screen. And so we can talk about limits from the left and limits from the right. So for example, if I were to talk about the limit from the left, right? The limit from the left, or the left-hand limit, another way of saying that, what we would then say is that the limit as x approaches 0, and we put this little negative up here as a superscript behind the 0 to say from the left. So the limit as x approaches 0 from the left of this function equals -1. And if we look, if we travel along our function from the left, approaching x equals 0, right? X is going towards 0. Where does my y value go? My y value goes to -1. So that represents my limit from the left, my left-hand limit. Similarly, if we think about the limit from the right, or my right-hand limit, we could say, well, the limit as x approaches 0, and we use a positive, a plus sign as our subscript. So the limit as x approaches 0 from the right side of this function. So as we travel along the function from the right, as x gets closer to 0, where does my y value go? And it never touches that value, but it approaches +1. So the main thing we want to note is this new notation. We have this superscript minus and a superscript plus. Minus means from the left, and plus means from the right. Okay, so we have different right and left-hand limits at the origin. And so what we're going to learn in this section is that if the left and the right-hand limits do not match, then what we can say is the limit of this function as x approaches 0, so the limit of the function as x approaches 0, does not exist. So the main point here that we need to keep in mind is that for the limit to exist at that x value, that we have to have matching left and right hand limits at that value. So the left and right limits must equal. If they're not equal, then we end up with a limit that doesn't exist. So let's look at an example where we determine left and right hand limits. Here, given the function over its natural domain, we're going to find several limits. So the function is f of x equals the square root of 4 minus x squared. And the natural domain for this is that x is between -2 and +2. So let's look at the graph. The graph of this function is the top half of a circle or a semicircle of radius 2. So let's look at some examples. If I asked you to find the limit as x approaches 0 from the left of the function. So 0 from the left means we are going towards x equals 0 from the left. And once we reach x equals 0 from the left, we find that we get a y value equal to positive 2. Similarly, we could say, let's find the limit as x goes to 0 from the right of the function. So approaching 0, and this plus sign superscript implies from the right. So let's travel along the graph from the right side towards x equals 0. And again, we see that output value is 2. So what we can say is the limit as x approaches 0, not needing that superscript from the left or right, the limit as x approaches 0 of the function is 2. And we know that it is 2 because my left and right hand limits match. If they do not match, if those two numbers are not the same value, we would write does not exist. So let's look at some other points on the function. So example D here. Let's look at the limit as x approaches positive 2 from the left of our function. So what does that equal? As x goes towards positive 2 from the left-hand side, where does my y value go? My y value goes to 0. So for part E, the limit as x goes to 2 from the right side of the function. And in this situation, does the function exist to the right of x equals 2? Is there any graph on the right side of x equals 2? And the answer is no. So in this situation, we cannot approach it from the right-hand side, and we would say that the limit does not exist. Therefore, the function, if we look at the limit as x approaches 2, not handed, no plus or minus there, it does not have a two-sided limit. We would say does not exist because these two values that we are looking at, they're not the same. If they're not the same, we say does not exist. So this brings us to a supposition. We have a theorem here. Suppose that the function is defined across an open interval containing some point C that we're approaching, except perhaps at that point C itself. Then the function has a limit as x approaches C if and only if, and that's a biconditional statement indicated by this double-ended arrow, if and only if it has a left-hand limit and a right-hand limit, and these limits are equal. Okay? So, as long as the left-sided or the left-hand limit equals L and the right-hand limit equals L, then I know the two-sided limit, the limit from either side, would also equal L. And because this is biconditional, it goes in either direction, if I know the limit, if I know the two-sided limit, then I also know each of my one-sided limits. Let's look at one further example in this video. Here we're given a picture with open and closed circles, and we're going to determine function as well as limit values given some questions. So we're going to do quite a few of these. So A, let's find the limit as x approaches positive 1 from the left of this function. So we are approaching x equals positive 1 from the left side. This negative superscript behind the 1 means from the left. And as we travel along that graph from the left toward the right approaching x equals positive 1, we see that the y value gets closer and closer and closer to 0. Although you'll notice here this is an open circle, so it never actually touches 0. It's approaching 0. Similarly, we could say, well, let's look at the limit as x approaches positive 1 from the right of this function. So approaching positive 1 from the right means we are traveling from the right to the left. We know it is from the right because there is a positive superscript behind the 1. And if we are to travel along this graph from the right toward the left, we reach a point where y is equal to positive 1. And since a and b, the left and right hand limits, do not match, then the limit as x approaches 1, our two-sided limit for this function, does not exist. All right, so we've talked about the limit, and remember, the limit is where the graph tends towards. To what y value are we going to? We may not be able to touch it, but what y value are we approaching? So I could ask you one further question here, and I could say, well, tell me the function value at x equals 1. So find f of 1. If I'm to plug 1 into my graph, my output would be where my solid dot is. So my function value here is equal to positive 1. All right, so that's information about what is going on at x equals 1. So let's look at some other points on this graph. I'm going to pause and erase my work. So here, let's look at the limit. We'll say the limit as x approaches positive 2 from the left of this function. So we have a minus sign superscript following that. That means we are approaching 2. We are traveling along the graph from the left toward x equals 2. And we see that our output y value here is positive 1. So if we look at the limit as x approaches 2 from the right of this function. So approaching 2 from the right means we travel along the graph from the right toward the left toward x equals 2. So we're going toward x equals 2 from the right-hand side. And in this situation, we see that our output value, the y value that we are getting nearer to but never touching, is 1. So for g, since the left hand and the right hand limits match, we can say that the limit as x approaches 2, my two-sided limit of the function, is equal to 1. One more part here on this question. If I asked you to tell me the function value, what is f of 2? That would mean we are going to x equals 2 and we are finding the defined point. And the point that is defined for x equals 2 is y equals 2. Okay? So let's look at one more example here. So let's find the limit as x approaches 4 from the left of my function. As x approaches 4 from the left, that means we are traveling from the left toward the right side. So we are approaching x equals 4 from the left, and my y value, my graph tends, it goes to this open circle, and that open circle would be at y equals 1. So how about j? The limit as x approaches positive 4 from the right of this function. Now, is it possible to approach from the right side? There is no graph to the right of x equals 4. So this would tell us that it does not exist. And since I and j are not the same, the two-sided limit as x approaches 4 of the function would also not exist. One last question here, L. What is f of 4? And my output value, I have a solid dot that looks approximately at 1/2. So when x equals 4, my y value equals 1/2. So I hope that helps you understand left hand and right hand limits better and how they have to work together to give us our two-sided limit.